Now, the reason that we're interested in determining Lewis structure is because the Lewis structure of an atom helps us to explain some of its chemistry, but also the shape of the molecule. And this will help us to get some physical properties of the atom as well. And to determine the shape of the molecule, we're going to use our VSEPR theory, or our valence shell electron pair repulsion theory. And the idea is that the electrons of the central atom are going to want to be as far apart as possible, whether they are in a lone pair or a bonding pair. And so they're going to repel each other. And so as a result, this is going to cause the atoms that are bonded to my central atom to spread out in a specific way, and that will determine the shape. Now, to help us to keep track of which shapes a molecule will have, we're going to use what's called the AXE method, where A represents my central atom, X represents the number of atoms bonded or bonding groups on the central atom, and E represents the number of lone pairs. So in grade 11, we're only required to know a few shapes. So the first shape would be our linear shape, which is an AX2. What that means is that there are two bonding groups on my central atom, and there are no lone pairs. In this case, they want to spread out as far as possible. It'll give us a linear shape with about 180 degrees between them. The second shape that we need to know in grade 11, AX3, where I have three bonding groups around my central atom, and so they'll spread out as much as possible, and it's trigonoplanar. This is a flat molecule. Then we have our AX4, where I have four bonding groups around my central atom, no lone pairs on the central atom, and it's tetrahedral. Then we have AX3E, where one of the bonding groups is now replaced with a lone pair. And this will cause these bonds to be pushed a little bit closer together. Not a lot, but a little bit. But we call this trigonal pyramidal because it'll look like a pyramid. And then the final shape that we will be looking at in grade 11, AX2E2, where there's two bonding groups on my central atom and there's two lone pairs. And we don't see the lone pairs, we only see molecules. And so it has a bent shape. So let's take a look at a couple of examples. So the first example is CO2. So the first thing we need to do is get its Lewis structure. And we get its Lewis structure the same way as we talked about in the last video, where first we identify how many valence electrons we have, then we determine how many are required to fill each of the valence energy levels, we can determine the number of bonds, and our number of lone pairs. So we have 4 bonds. Okay, and then again we just summarize. Carbon is our central atom. If carbon is present, it is most likely going to be your central atom. Okay, so then we are going to follow our steps for our Lewis structure. We write our central atom to peripherals, join them with bonds. So I put 1 bond, 2 bonds. I still have 2 bonds. So then that's 3 and that's 4. So these atoms are double bonded to each other. And then I'll put my lone pair, and that uses up my lone pair. So this is my Lewis structure for CO2. Now, if we look at our AXE format, on my central atom, I have 1 bonding group here, and I have 1 bonding group here. So that tells me on my central atom, I have 2 bonding groups. So as a result, I'm going to have a AXE shape that is linear. So therefore, this would be the shape of the CO2 molecule. Okay, let's take a look at another example. Sulfur dichloride. Again, first thing we need our Lewis structure. So we determine how many electrons we have. We determine how many are required to fill the valence energy level of all of the atoms. We determine our number of bonds. We determine our number of lone pairs. Okay. Sulfur has a higher bonding capacity than chlorine, so it's our central atom. So we've just summarized. So now I write my central atom with its 2 peripheral, and I join them together, each with a single bond. First step. That used up my bonds, so I have no more bonds to place. Next we place our lone pairs around our peripheral atoms. And so now I've used up 2, 4, 6, 8, 10, 12. That leaves me with 4 lone pair electrons still. And our rule said if after our peripheral atoms are satisfied, we have lone pairs left, they go in the central atom. So therefore, this is my Lewis structure for my sulfur dichloride. So now I look at my AXE. In this case, my central atom, I have 2 bonding groups. So that's an AX2, but then I also have 2 lone pairs. So it's an AX2E2. And that means that it's going to have a bent shape. So therefore, this is my shape of my sulfur dichloride.